Hello, welcome back PlayBASIC coders. Let's dive into this Vertex Objects thing that's been going on and just to refresh your memory. This scene is using the Vertex Objects library layer underneath to do all of the 3D rendering stuff. And what it actually is quite simple. It doesn't actually have primitives in it, so you create the primitives, but it lets you create a 3D object. It has a position in space, lets you create a 3D camera for viewing objects in that space, handle the rotations of them, scaling, etc. And then pass a mesh that represents a shell of an object out to the rendering system, out to the scene. This one has the updated with subdivision for better perspective and that kind of stuff. So clipping's better. We've got an ability to improve the perspective up near the camera. If we go up here near a cube again, it's more evident. That's with it turned on. Let's turn it off and we'll see how she warps. You'll notice one thing here as well is you can actually have faces within the same object that are different types. You can see it in the back there, but it's kind of warping around. So it just helps you hold perspective, and it works for ground as well, by the way. So you actually get, otherwise you would see the colors at different orientations, shearing and blending and stuff. That's pretty much what I wanted to show you. Open her up. The actual library itself, it's still the same structure as what it was before. So it still works with older examples. I was kind of limited by how that was laid out to what I could add to it now. And given that I was really just updating the transform mesh to scene stuff, to make it simpler, that was my main objective really. So in here, for example, you've got this translate object, vertex object mesh to scene. Now this layer doesn't have a way of creating a mesh. This is actually what I want to talk about. So in this version of the library, you can have a vertex object that has, what's the structure? It's probably easier to understand then. Here's our basic structure. This is the original one. So we've got like, does the object exist? Do we actually need to render it? Position, angle, scale, rotation mode. Is it rotated in XYZ order or ZYX order? What's the projection mode of this thing? In other words, is it an object in space or is it a camera itself? And if it's a camera, what projection are we using? So it didn't let you have a vertex buffer or a face buffer or a mesh attached to the object. So that meant that all the user code that used this had to manage the vertices themselves, had to allocate a buffer or use an array or whatever you wanted to put this data in, and then get pointers to this and feed it to the rotation routines themselves. So it was quite low level and quite tactile really. Now this has been updated, so we've added this parent structure here and we're adding these ones here to it. So we've got a vertice buffer, a mesh buffer, and a flag for back face removal. Because translate mesh to scene, even though it wasn't documented, it was used in a bunch of old examples. And one of the parameters is, do you want back face culling or not? Sometimes you would, sometimes you wouldn't. If you knew what you were rendering didn't have any back faces, then there's no point doing that. So the newer code here is really just about, go through new vertex objects. We just allocate a PB bank for the structure. grab a pointer to the first byte in the structure. It's the same as effectively going, bank equals this new, except we can use the PB bank system to check whether something exists or not. You could have an array of pointers. You could do that. You could emulate your own array, but this is the way the legacy routines have been done. So I've just maintained the same thing. When we create something, there's an initialization pass that runs. So we specify the default settings of the object. If you want vertex buffer attached, it would be set to anything above 0, meshes again above 0. Each vertex is just a triplet of 3 floats, so x, y, z, so it's a vector 3. And this has been updated to use the vectors library to just reduce the code and kind of reinforce that direction, really. In some cases it should perform better just because of that, but some places I haven't bothered, like setting a projection here. You could use the set vector 2D and make this 2 operations into 1, but there's a point where there's diminishing returns of that stuff. Maybe it does, maybe it doesn't. Alright, this is the Vertex Objects library. So what has it done to the rest of this? Well, if you look at the objects library, we've now just got a vertex object. So for each object in a PS3D scene, we have a vertex object that represents its position, rotation, scale, and its how many the vertex buffer and the face buffer. We don't really have a way of initializing the faces, and that's kind of the complicated thing about this system, is it's quite low level. I mean, it's higher level than what it was, but it's still a bit low level for, I think, most people, but we'll see how we go. There's a little library here, mesh, that's built into here for initializing the faces within a mesh. And you kind of step through the mesh buffer face by face and then specify what you want. That's how the cube back here was done, by the way. If we run him again, we'll pinpoint him out. They're just set to be random, so each face in a cube can have, each face can be random, whether it can be a texture. In this case, we've come up with Gouraud on the side there. There's one there. So you can have all 3 different face types in the one object. So you can actually have point sprites and lines as well in one mesh. How you do that's a bit clumsy, because the renderer expects all of the data packed in each operation to be set in a way that's so if we have a line, we have to set up a line face, and then if we have a polygon after that, 3 or 4 face, 3 or 4 points, that data is laid out in memory, not on even boundaries, but at the size of the last thing you wrote down. So something like a point sprite, which just has one vertice and some basic settings about itself, like the UV coordinates, the texture, and that kind of stuff. You can see here that each face has different render settings as well. So we've got a ground face, and I've made flat faces be transparent in this particular demo. We'll have a look at that, give you a sort of sense of what's going on. And you could, my point really I'm trying to get to is, months ago I was talking about there needs to be like a mesh library to create meshes, and this is one of the things that I've always felt that these kind of products, these kind of simplified languages that have a 3D engine in them or attached to them or whatever, that's what they were always missing. Like, well, when I think about this, I think back, about Dark Basic. We'll go through this create box, which is how the cube is made, by the way. So I've just got some random code baked into this to randomly pick what sides of the cube are doing what. So to create a cube, we make a vertex object which has this many faces, this many vertex and this many faces. We just check that, did you allocate something for us? If so, great. We grab the vertex object bank, which is just a PB bank index. We ask, hey, give me a pointer to this thing. And I could use it, just give me the bank index here. But this function here is a little bit higher level, as it returns not the address of the structure of the vertex object. It returns the first vertice of the actual vertex buffer. Once we have a pointer to it, then we're in control of what we write and how we write it. If we write it the wrong way, you'll crash, But anyway, so we're setting the first point top left in the front, moving to the next point, setting the next point sort of clockwise, moving each time we're stepping from where we wrote to the next one. And that sets up our vertices. So calling a built-in function here to compute the radius, which is used for clipping. So when we try and draw a batch of these objects to scene, we just reject anything that's not going to be in the view frustum. And it uses the radius as a quick way of determining whether it is or it is not going to impact the scene. Next part's the face generation. This is a bit more clumsy. It's cleaner than what it was, but it's still a bit clumsier than what I would like. So same thing as before. We're making a pointer. We're asking the vertex object system, give me the pointer to the very first byte in the pre-allocated face block. So if I allocated, where is it? Number of faces up here. If I set this to 0, we wouldn't get any allocated faces. It would just assume that you're going to do that task yourself. That's how it retains compatibility with old examples. So old examples that manage the verts and faces themselves, they do that stuff. You don't do it. Alright, so we've got a list of faces, and when the face is allocated, it's allocated at the largest face size, and that would be a quad, right? So a quad has a header, it has basically the type of face this thing is, and we'll look at the structures in a second, and then followed by the 4 vertex datas after that. So we have, for each vertex we need things like what index of the vertices up here are we going to use for this to form this polygon. What's the UV coordinates? What's an RGB for each vertex? So if we draw it as a flat shaded side or a filled side, vertex 0 becomes a control color. You should really set all the vertices to the same color, because when it becomes clipped or subdivided, it will actually then it becomes important if those things are enabled. Anyway, so to make our cube sides, I've got a list of these things here. What vertices to stick together to form each of the 6 faces. So I can then have a little loop that runs through and just does that. For something like a cube, that's fine, but for a bigger object, probably you would have to actually compute all that stuff as you went through. Now let's look at the processing loop. So we've got a few different fill type variables here where I'm just randomizing the choice between, hey, give me a value from 0 to 1000. If that value is above 500, we'll texture this face In other words, we initialize the face, which is this header. You can fill all the stuff in yourself, that's perfectly fine. All the functions are doing is what you would be doing. This is the mesh header for each face. And then for each vertex this particular face has. So if it's a point sprite, it really is this. It's a header plus a vertex. If it's a line, it's a header plus vertex 1, vertex 2. Triangle, vertex 1, same, and a quad, it's the same thing. So ideally you would use these versions of the structure. So that gives you the size as well, so you could just use size of to step, and it would know how many bytes this structure takes up, and then step our pointer to the next thing in memory. Here I'm not using that, I'm using like a little wrapper that was in this library originally. I've kind of just tweaked to run with the changes of Vertex Objects. So initialize face sets how many vertex are in this face. Now, what you probably should have really is, like, since we have 4 different face types, a point sprite is basically it's a centered sprite that faces the camera. So think particles when you think of the stuff. It's a classic implementation. Since we know it's a 4-sided polygon, we use the init 4, which is, we're setting our mesh to use vertex 1, 2, 3, and 4, whatever they are, in our cube. Texturing the face 4, so we're applying. We probably don't. Like a better way of writing this function would have been to have just texture face, and then it could read how many faces to apply the texture to. How many of the verts apply. And same with the mesh color here, it's just applying a random color to the face. Since we're randomly making the mesh, we're going, alright, if you're below this value here, we'll use a fill type of face, and it's set to 32. These are ink mode settings, by the way. So these classic ink mode ones here, if you went to the help, and 32 is alpha blend 50/50. Look, I think you can use alpha blend, I'm not sure that's going to be supported, but most of these will work. Alpha addition and or XOR inverted subtraction. Hang on, what was that last one? Inverted subtraction. I'll have a go at that. Inverted alpha subtraction 4096. So anything that's a filled face in those cubes should do some weird stuff. Might help if I commented that out. That'd be good. Let's find a cube. Oh, that's how that looks like it's transparent. Yeah, there it is. Sorry, the inverted subtraction. You were taking the source color and subtracting it from the destination, or other way around, taking the destination and subtracting it from the source, so you get this weird inversion of colors. You might not have seen, this is the wireframe stuff beforehand. These are just so you can make it a mesh that's just wireframe, or a mesh that has point sprites, wireframe elements, polygons, as in 3-sided or 4-sided polygons in the one mesh, and they'll get sorted and managed for you. But this is the legacy approach for creating meshes. Now, the point of what I'm actually trying to get to is that I mentioned ages ago that I thought having a mesh library built into PB is actually a necessary thing, and this is why. Like, this is the reason why products like, I'll go back to Dark Basic. This is why I had a bunch of built-in primitives and kind of didn't let you do much for the primitives. You could make a cube, make a sphere. I forget what was even in it now. I think it was like cylinders as well. You know, we could have a bunch of these primitives, you know, ourselves. That you could make your own primitives and have them included optionally. So if you don't need them, you don't need them, right? But the limitation of that is the same as this limited box here. Well, I mean, technically, I could change the box faces while this thing's running. I couldn't do that in VertexBasic. Or I couldn't do things like turn faces on or off. You can do that with this if you set the fill type of the face to something that it doesn't recognize, which is this fill type variable here. There are four possible settings. You know, filled, Gouraud, textured, and texture and Gouraud, or shade textured, as it's referred to in the more contemporary. I think the commands was called that. But that's the same principle. You know, so in DB, you kind of, to make something custom, you had to make it in a 3D editor. Now, often you didn't want to do that. You wanted to, so eventually they succumbed and they added a memblocks solution, which meant that you laid out faces and vertices manually. Basically, what this is doing here. This is still a bit low level. Like what I was saying before about, I think it's better to have, well, the particle example here is probably, this shows how a particle sprite is created. These have two different modes at the moment. They can be a filled type, and if it's a filled type, it will default to being a circle. There's only one of those options. There's no control modes to pick what shape it's going to be, unfortunately. We can set it to be a textured. I hope it's got a texture with it. Where's, are they in the scene? Oh, there's one there. Yeah. Add a few more of those things. So they're just are being added to the frame buffer. There's heaps of stuff below the camera too. Like if you look at that, there's heaps of stuff that should be out of view that can be culled away. So this is actually an image. Like it's drawing an image scaled up to this. What I was thinking about is you could sidestep that and have those be like a Gouraud. We'll call it like a polygon, like a disk of polygons, really. Which means you don't need a texture. You can set the color, and you have, you know, really limited point sprites. But these are actually textures. They always face the camera, so the point in 3D space is rendered into form a scaled image. Well, actually, you've seen the same thing done in PB a lot. Every particle demo you've ever seen uses some variation of that, really. Whether it's 3D or 2D or whatever. It's the same thing. This shows the actual creation of the mesh. So we're running through, randomly just generating a bunch of vertices, giving it X, Y, and Z. So the object has an origin, and these vertices are relative to that origin. So when we rotate something in space, it works out where it is relative to the camera. All that's good stuff for us. That's how we used to do this stuff. You'd have to allocate the face buffer yourself. Don't need to do any of that anymore. It's all done through here. So when we delete one of these vertex objects later on, it cleans up the buffers for us. We don't have to do that stuff anymore. We've got two different sizes for our vertex range for our simple, you know, particle explosion or whatever, or particles. And the faces, we're actually here. I'm using the point sprite mesh type, or the face type. You might want to think of it as running just counting through the faces, setting the current address is to this point sprite, initializing it as being a single vertice structure, because internally there's no, that's how it determines what type to actually output and what to do with it. For a point sprite, it has to generate a polygon, has to do the clipping of the polygon, and then pass it through to the scene process to insert that for Z buffering later on. So you're not just drawing an object there and then. It gets fed into the scene for then, so you can composite elements together, or do partial passes, do a render, do a partial pass, render, all of those things. Which you would have to do if you're serious about making a little 3D game and avoiding some polygon popping here. That's probably the easiest way of doing it. And that gives you the benefits these days of polygon subdivision to improve the perspective, so it looks better prospectively. Anyway, so in this point sprite structure, we have the header part, which we're setting up here. We're going, hey, use this texture, so each sprite, each face in this thing can be a different texture. It's important to understand. And this one actually has one subtle difference. It's the size of the point sprite is determined by the UV size. Here, these have nothing to do with the texture. In this is a very unique case, because I didn't want to add different change the structures now, because that would make the translate mesh to scene stuff incompatible with old demos, and they would just crash for no reason. So I fit everything into how it works already. Yeah, it is what it is. So we set the color of the point sprite, and we move to the next sprite, or sorry, the next face within this mesh. We're using the size of to step how many bytes this point sprite structure is forward. So we don't have to worry about this stuff. We just have to use the PB to do that stuff for us. Set it back to just, well, this is obviously set to being random, so we'll see what we get. And there's more junk in scene than I wanted, but there you go. So you got a mixture of textured point sprites and circles. For whatever reason. Makes no sense. You'll notice the ground is coloured too, by the way. We've got a bit of, flickering here and there. Fair enough. What do you expect? A lot of that's coming because there's objects below the ground. And where the subdivision occurs, particularly when we have edges that are subdivided, we have a high resolution area to a low. See that bounding there? We've got different sections in here. When that point there is generated, the central point, say, it may or may not lie exactly on the line of this other line, because it might be rounded. Isn't math great? Yeah, look, you can make some pretty weird looking stuff. That's kind of a point, make some weird looking stuff. And if you think of it laterally, you can get to do some stuff that it doesn't consider possible currently. But getting back to my point that I was talking about months ago, is that having a mesh library would sort of be a high level way of generating these meshes, and then a safer way of generating the meshes. So you can sort of use and abuse the mesh creation process dynamically, spit out some weird polygon mesh, or modify meshes, which is I think it's an imperative thing that I literally harped on. Lee Bammer at one point. I probably annoyed the living crap out of him. about why can't we modify built-in meshes. All I wanted to do at that point was, hey, I can create a cube, that's great. I can create what they used to call as a matrix, which is like a height map thing, which is what the terrain here is, just like a matrix height map. I'll demonstrate that, I guess. You probably seen, well, you would have seen this stuff before anyway, so it's just set to be basically one height. Right. So the height map just means that across the grid, the Y can vary and the polygons are stretched between each one, but they're actually set to a rigid grid. I said this is great, but what would be great is we could have an object type where we could rotate that freeform. We don't need collision from it, but so you could have like a curved edge point where you could set the vertices up in a particular format and curve and mold them around shapes. So you could actually have you could take a mesh like this and then apply a secondary mesh on top of that, and then hopefully punch out the mesh faces below it, so you don't have Z fighting between the two. Imagine having an interior scene like Aliens where the corridors are not like square boxed off. You know, if you made corridors out of cubes, that's what you get. But what if the cube faces were, or if you had a plane, or where you had, hey, subdivide this thing. Basically, what this does here. So you give me a flat plane of X by X polygons, and let me modify just the height component, and then I'll spin and orientate this thing into position so I can form rounded edges and things, or form like, you know, one side of a sphere out of it almost, that kind of stuff, you know. And they wouldn't buy, they didn't get it right. Pretty much what you had to do in Dark Basic was, back in those days, you had to render your own object. I mean, create an X file and then reload the thing back into memory. So I spent a bunch of time making large terrains, just seeing how functional I could get this thing to be. Like, it wasn't pretty, it was as ugly as anything. But because I wanted to use recycling objects in the scene, this doesn't do that. Every object in the scene is unique, you know. So we've got the same sort of texture quality everywhere and stuff. You don't need that stuff. There's no LOD in this as well. Yeah. By LOD, what I mean is, as you move away from a texture, it would use a low resolution version of the texture. In this context here, you would have two versions of a mesh, because the way mesh handles UV coordinates, the UV coordinates are locked to the faces. Yeah, anyway, long story short, so what the mesh library would do is really, it's a way of generating a list of polygons for rendering without you having a low level, have to manage the stuff at a low level all the time. That would let you do things like add or delete faces, reposition vertices, update normals, check the faces of things. Just, it doesn't have to be a whole long list of complicated stuff. It can be a bunch of simple things that can be used as the basis of other things. I don't know if I made my point or not. Well, I probably have anyway. Alright, that's enough for me. I have to go out anyway. So, until next time, I'll see you. Bye.